Today we'll discuss criteria for optical isomerism, right? What are the criteria? What are the criteria? Now, for a compound, note down this, for a compound to be optically active, it must be non-superimposable, right? Superimposable, on its mirror image. I'll explain what is non-superimposable, right? Just take the notes, I'll explain it. Mirror image. A molecule optically active must be non-superimposable. That is one of the criteria that you need to know. A molecule that is non-superimposable on its mirror image is called chiral compounds. Chiral compounds, right? Chiral molecules. Two important definitions. Now we have learned this optically active compound. Optically active compound is a chiral compound, must be, and has to be non-superimposable on mirror image, right? What does it mean? Suppose you put right hand side on the mirror, you will get left hand side, right?
Yes.
This is called non-superimposable. Suppose if we take on glass in front of the mirror or the water bottles, there's no difference, right? Same. It is called superimposable. That will give achiral compounds. So non-superimposable, note down this. Non-superimposable will be chiral compounds, right? You understood what meaning of compound, but only superimposable will be achiral compound or optically inactive Okay.
Yes.
Optically inactive, right? This is optically active. So understood what is optically active meaning? After optically inactive. Optically active means non-superimposable mirror image chiral compounds. Optically superimposable means achiral compounds or optically inactive compounds. Have you what is the difference? Now you explain. Now we'll determine what is chiral compounds. Now chiral compound. I will do that. Now you need to know what is chiral compound, right?
Yeah.
What is chiral compound? Now chiral carbon.
Chiral compound or carbon?
Carbons. If you chiral center, there's this center is called, that molecule is called chiral compound. Okay. Now suppose it's a carbon, right? We understood this. Carbon has 4 hands, right? Suppose A, compound A, is a B, is a C, is a D. 4 different atoms of groups. Is it 4 different atoms or groups? 4 different atoms or groups. We have this compound called chiral carbon. A carbon bonded to 4 different atoms or groups known as chiral carbon. Am I clear to you?
Yes, sir.
Note down this. A carbon bonded to four different atoms or groups. This is meaning meaningful or groups. Groups is known as chiral compound. Known as chiral carbon. Am I clear to you?
Yeah.
Now, so I'm giving an example. Tell me. Suppose CH3, C, Cl. Tell me how many chiral centers are there?
Two.
I mean, just check how many chiral centers are there this molecule. Then you check the definition what I written. Then you tell me the answer. Again, I repeating. Any carbon, four different atoms of groups. That carbon is called chiral carbon, right?
Yes, sir.
Tell me example. This is how many different atoms of groups? How many chiral centers are there in the particular compound?
Three.
Hmm?
Three.
How?
CH3NH. Methyl
Hmm.
group.
How many chiral center for this particular compound? Chiral center or chiral carbon for this particular compounds? How three? Tell me. Only one. So this is only one atoms. Another atoms.
Yeah.
Another atoms. Another atom. So this is only one chiral carbons. Am I clear? Only one chiral carbon. Am I clear to you?
Okay, okay, like that. I was counting the
Yeah. That's I told you.
active.
Carbon has four different groups of atoms. That's why I'm meeting this atoms of groups. I highlighted.
Okay, fine.
So the hydrogen different, these different groups, atoms, ethyl group, this is chiral group. Tell me this example, how many chiral centers are there? This is only one. Tell me how many chiral center. Quickly tell me. Okay, this is, let me explain. This is two. Suppose this carbon, this is only one,
Two, three.
and whole group two. So this is one. Another also same thing. One, two, three, and this group. So two chiral center, right?
Yes.
Two chiral center or chiral carbon or center, how to be made. Am I clear to you? Yes or no?
Yeah.
Yeah, question will come. Another question now. How many optical isomerism? You know what is optical isomer discussed? Optical isomers for these compounds. Optical isomers for this compound. This is very important for your board as well as competitive exams. How many? They have only one chiral center. This is two chiral center. There's a rule called 2 to the power n. When total number of optical isomers. So what is the total number? 2 to the power 1. It will be equal to 2, right?
Yes, sir.
Now how many? Equal to 4. So you have understood that how to determine the chiral center or chiral carbon, followed by how many optical isomers for the particular compounds. It's very regular questions come both in board as well as competitive exams. Am I clear to you? Any doubt?
No, sir.
That is yes or no?
No, sir.
Sure. Next is now what we have learned. We have learned optically active chiral compounds
Yeah.
with non-superimposable. If superimposable, then achiidal, spelling mistake, achiidal spelling mistake, chiral. Chiral compounds or optically inactive compounds, right?
Yeah.
Then I've discussed the chiral carbon. What is the chiral carbons? Four different grouped atoms. This is called chiral carbon atoms. If you know this chiral center, then you can determine optical isomers to the power n formula. That will be that. Next is now enantiomers. Enantiomers, right?
What in
Enantiomers. First is the definition. A pair of stereoisomers stereoisomers which are non-superimposable, right? Superimposable, superimposable, impossible, mirror image, mirror image of one another, are known as enantiomer, right? Now I'll explain now. Enantiomers.
so what's the spelling? A, sorry, E.
Sorry. Enantiomers. Suppose you have this compound C says 3 hydrogen beer cell mirror, right? So 3 cell see, this is the one compound, this is two. That is, see the compound left hand side hydrogen, right hand side Cl, right?
Yes, sir.
They are interchanging. Cl has come right hand side, it has gone interchange. Is it superimposable or mirror image, right?
Yeah.
These two isomers called enantiomers. So compound 1 and 2 in the diagram are enantiomer of another. Am I clear to you? There is a pair of stereoisomers which are non-superimposable mirror image of one another is known as enantiomers. I will determine. Suppose left hand side, if you see, left hand side they are interchanging. Hydrogen has gone right hand side, chlorine has gone left hand side. This molecule. This part is interchange. This is called enantiomers. Am I clear to you? Yes or no? Hello.
Yes, sir. Yes, sir.
Okay. Any doubt?
No.
Okay. Now, little bit you have to know the properties of enantiomers. This is important for a multiple type question. Properties of enantiomers. Enantiomers. In properties of enantiomer, number one, enantiomers have same physical properties like boiling point, melting point, solubility, dipole moment, refractive indices are same. Therefore, pair of enantiomers cannot be separated by physical technique like fractional distillations, crystallizations, etc. Number two, enantiomers have same chemical properties towards optically inactive reagents, but they react differently with optical reagents. Number three, enantiomers have same magnitude of specific rotation but opposite sign. In a compound containing n chiral carbons, there can be 2 to the power n minus 1 pair of enantiomers.
Okay.
Next is the mesocompound. What is mesocompound? Compounds compounds containing chiral carbon but superimposable on its mirror image is known as mesocompound. Let's see the example. Suppose if you take CH3 cell CH3, A the mirror, CH3 is the B cell hydrogen, cell hydrogen. If you see, A is superimposable of B by rotation of 180 degree on the plane of the paper. Hence, A and B are the same isomer as well as the optically inactive. These are optically inactive compounds. Why this? Because if you cut this section, this part, this part, this part are same. This part, top was A and this part is same. Okay, this is called plane polarized light. Like this plane of symmetry. Plane of symmetry. Due to plane of symmetry, this compound is optically inactive because plane of symmetry bisect the molecule in two parts in which one part is mirror image of other. Am I clear to you?
Yes, sir.
This part. That's why it's optically, although it has chiral center, but optically inactive. So this is important for your exam purpose. Meso compound will be optically inactive, although it has chiral carbons. Am I clear?
Yes, sir.
Because of the plane of symmetry. Next one is the racemic mixture. This is important. What is racemic mixture? Racemic mixture.
RA.
RACMIC. Racemic mixture. It is a mixture that contain equal amounts of enantiomers, right?
Full amount. So can you shift your note?
Yeah, so it is a optically, it is also racemic mixture also is a optically inactive compound. Optically inactive. This is important. Racemic mixtures and mesocompound are optically inactive. Mesocompound optically inactive, racemic mixture optically inactive. And another important point that comes in exam. Racemic mixture can be resolved into enantiomers through a process called resolution. Means This machine mixture can be separated by a process called resolution. There you write plus minus 50-50. 50% on one isomers, another 50% another isomers. And this process is called